Okay, I think before I started the wireless, I have a very quick review because in maybe 2 years ago, I have a chance to review the rescue robot. Okay. So I don't know, I already upload this or not into the e-class. Can you help me to check? Already have this lecture, right? Okay. So from the 911, okay, the Texas A&M University have a center of the robot assistant research and the rescue, what we call the CRA, CRASAR. Okay, so this is the real picture that using a robot into the 911 for the rescue or the investigation. So somehow in a Taiwan earthquake, okay, a doctor, Robin Murphy, said that the robot for the rescue purpose may need to go deeper than 18 to 20 feet, maybe 6 meters to 7 meters, okay? And that camera on a probe or on a broscope can go into, I mean that a camera, just as I said, in the next week, we will use the camera in the Raspberry. And also you can use the Raspberry to do a robot, okay? So here, I mean that for some of the earthquake in the Taiwan, maybe we need a robot that can deeper into the maybe 7 meter steps. And okay, that's why, because if we have a camera, we can understand the inner layout of the structure. Because if we have already the building collapse after the earthquake, so we can use the camera to find the layout and to decide how to go inside and maybe saving some people already buried. And here it's the same, okay? Understand the inner layout of the pixie stick of the robot, okay? And carry out the tubing allowing survival have the water, okay? This is another function. Okay, so I would like to say right now the robot for the rescue purpose can be applied maybe from the 911 and 2010 and also the 2011 Christian Church earthquake. I would like to say in that time, I'm in New Zealand actually, to 2011. Okay, in that time I go to a conference, and before the earthquake, we going to the maybe the south of the Christ Church in the New Zealand, and at the night and the last night, the earthquake maybe less and more than 1 minute, more than 1 minute. Okay, so after the earthquake, we go into the downtown of the Christian Church. Some of the church, the building of the church already fell. And okay, so lucky in that time in the New Zealand, but without any hurts. Okay, so here I would like to say we can combine the different kind of the sensor on the robot. So you can find here, this is the type of the robot with the roller, okay, different kind of roller and the sensor, okay. And this is the sensor, maybe with the night vision and maybe infrared spectrum. So this is the queens, and let me show if this can be played. Sorry. This is the queens have the camera, microphone, position sensor, sensitive detector, maybe the range detector, okay, and the laser range detector, and also the Wi-Fi and the infrared thermometer, thermal camera, and also the carbon dioxide sensor, because you need to check out the air quality. So here, let us show you. And this is from the Tohoku University and CHIH Institute of the Technology. Can you see that? Maybe I. Okay, it is trying to simulate the robot in a collapsed building. So one of our Professor Lin, he has a class to use some of the M-board to do the robot. Okay, you can find right now this kind of the robot is without any cable, because all the signal transmit in the wireless. But in the 911, in that period of the time, okay, they're using the cable type because they still need use the cable for the communication and the operation. Okay. And this one is from the Taiwan Normal University, from the EE, the Professor Wang. Okay. And one of the very unique sensor is from the Xbox Kinect. Have you ever played that before? Okay. Because that sensor is using the infrared sensor and also the range sensor for detect the distance. So they use this and also the thermometer to some place without the light. So you can find here, this is the Kinect sensor. Yeah, you got Xbox 316. So what is the new version of the Xbox? I don't know. I know that the PlayStation will have a fifth generation. Oh, I know that right now there's a game GTA 5 is for free, right? Okay. Actually, I played GTA 2. Yes, maybe 10 or more than 10 years ago. Okay, but it takes a lot of time because this is a very different game. And of course, the China have their own robot for the rescue purpose. But you can find this is a very similar with this one, the text AMM. Okay, I think it may be the copy from the text AMM. And here, this is another robot, big robot for the fire, safety fire. But you can find they still have a need a water line. Okay, for some place. Do you know that in the Taiwan, each year, we may have maybe 5 to 10 dies in a fire station when they try to have a rescue during a fire case. Okay, so is there anyone have the iRobot in a house? So the iRobot originally this is for the clean the house, but right now they also propose some of the warrior robot. Okay, with the handy robot hand. But you can find this the type of this kind of the robot most the same, right?
Boston Dynamics, they make walking robots.
Yes, but you can find here this kind of the robot have a higher maybe the sensor and also the IMU, the initial measurement unit. Okay. So also the thermal image laser range. Okay. This is maybe for the military purpose. A military purpose. Okay, here this is the report I found from the internet that introduced very detailed to show that this is the sensor. So from the beginning of this class to now, right now, I think you already know the most sensor with a different principle. And different sensor maybe can be used for the different purpose. So this is a chart and table. For example, here, this is a very special infrared camera, maybe for the body heat. And the last one, I don't know what it is. Maybe you can answer me next time. The SpO2 can be detect the blood oxygen. I mean, when you find some body or maybe still alive, they will check the body oxygen, the bloody oxygen. It means that it is still alive or already dead. Okay, it's very, very unique. And also, I find some of the paper. Okay, review the search and the rescue robot for the victim during the earthquake. So I already show you some of the sensor. But I would like to say, one of the most critical problem is how to define your position indoor. For outdoor, we can use the GPS, right? But indoor, for the building already collapsed and you have your robot go inside of the building, how can you check and position, have the position of that the robot? That will be a big problem. Okay, this is another review. Okay, you can say this is another problem because the wireless communication is not reliable, especially in an indoor or underground environment. Okay, and the third one is that robot need a battery. If you try to enlarge the battery, means that you may have a very heavy weight of your robot. Okay, so this is a trade-off problem. But right now, I think the technology of the battery already improved. Okay, if anyone drive the electrical car or Gogoro in Taiwan, no, you can download the app, and there's a very friendly Gogoro. I mean that you can rent Gogoro anywhere. But I think maybe need a credit card to pay the fee of the rent. Okay, here another kind of the robot. It is called the animal inspired cockroach type, snake type, cockroach type. Okay, so here this is a video maybe from the Russia university. Okay, they build a very small robot like the real cockroach. Okay. Oh yes, in the last time I already give you some of this the narrow, right? And I also upload a picture how to, because you need to choose the setting for the upload the code to the nano. Okay, and this one maybe can be the core of this kind the cockroach robot. Okay, and this is the snake one, a swimming robot. Oh, a little bit cannot be seen. So can you see that? Okay. Okay, because this is just the animation, so let us to show you the oh, here. I think this is a prototype of the swimming robot. But you can find it is still need a cable for the control, the movement. Okay, very good. And this is another snake type, but it is only for the camera from the Tohoku University, Japan. Okay, maybe you already find it from some movies, right? I can use this to check the vision. But actually, I think you already made, some of you already use this because you will have to check the stomach egg. Okay. Okay, I think this is very useful for some of the soil system or the pipeline underground. Okay, and this is another animal inspired. Very cute. Okay, and then here is another one, very easy one, like toy. Okay, oh, climbing. Wow. Swimming. Actually, you can use the Arduino for very simple control of this, maybe with a wheel. Okay, but I like to say it is try to simulate a very rough environment, especially for the earthquake. Okay, this is another one, like the fish. Even on the ice. Okay. Okay. And is there anyone seen a movie Prometheus? This one? Okay. Uh, when they arrive a new planet, they go inside of I mean, I don't know, the tomb or the cave, and using a ball to scan all the structure underground. So if someday we can use this kind of the technology, wow, amazing! I just put the ball and let it fly and scan all the structure. Okay, so this is I mean, finally, after the scan, you can know the shape. It is like the pin, building information system. Okay, but I would like to say, based on the current technology, can we provide some kind of this kind of the robot with the search, positioning, and the communication? Okay, there will be a critical problem. But here, actually, we have some of the ball for the image for the different 360-degree image capture. Originally, this is for the military or the police purpose. Okay, stop here, and this one will be easy. It is a surfboard. Okay, let quickly show you the result. I think just put a different direction camera in the ball. Okay, and finally, you can use integration technology to integrate the picture into the 360-degree. This is a force sphere. You just threw the ball, and you can take all the picture simultaneously. Okay. But I would like to say, you can think about, because in the later we are talking about the wireless communication. So Wi-Fi or Zigbee or Bluetooth or IPCOM still used for the indoor positioning system, okay, IPS. But we have a non-wireless methods. One is the magnetic, and then the other one is the date reckoning. Because we can check out I mean, if you can use the accelerometer, you can use the integration to know the position, to know your trace. Okay, and this is the story, right? The tale. You need to use a good, like the rocks, not the breast, for the positioning. Okay. And of course, right now another approach to the mind, the mind engineering. They're using magnetic communication, okay, on the ground. So I have some of the topics. Maybe you may have interest with that. One is the robot hardware. Can we have a very good animal-inspired robot in the future, or even just like the ball from the movie, or the sensing and scanning? Okay. So right now we have a very good LiDAR. What is LiDAR? What is a LiDAR? Okay, so it is also a ranging. You can detect the distance and the displacement using a laser. Okay, laser scan. And maybe next time I can show you a movie regarding using a LiDAR to check out the dinosaur behavior. Okay, and of course the tracking and positioning. Okay, indoor or the minor response. So it is a very quick review to show you the rescue robot. But I would like to say some of the sensor and some of the technology we already show you before. So you can think about it. This is another field using sensing technology, especially for the rescue purpose. Okay. Is there any problem? No? Yeah, of course. We need to go on, and for the next, I would like to show you a very quick understanding of the wireless sensing network. Okay, so the first, I would like to have a very quick outline, including the wireless routing protocol. But here, I will not talk in detail because I'm not an expert in this area. So I'm just trying to introduce some of the very important protocol for you for the preliminary understanding. And here right now, this maybe 3 or 4 years, a low power wireless communication like the Zigbee, Z-Wave, and even to the LoRa, NB-IoT, etc. Okay, I will show you in the second part. So what is the wireless sensor network? Actually, the idea may be mentioned about 20 years ago from the UC Berkeley, Professor David. He tried to develop what we call a smart dust. each particle can detect maybe the environment. So right now we're using some of the sensor, maybe Arduino or like Raspberry with a sensor to detect the environment target. So somehow it is the big smart dust. Okay, and with this smart dust, we can have this sensor node. Each one is the sensor node. And how can we communicate between each sensor node and go back to the sync node? Okay, so all of this is what we call the wireless sensor network. Because I think some of you still need the Chinese, so I prepared the Chinese. So before we try to implement the wireless sensing network, we try to design a network for some of the purpose, like our NCU slope. You need to consider some of the index. First one, fault tolerance. Can you accept maybe 80% or 70% of the fault tolerance? Okay. Second one is scalability. Okay. Much flex to extend the size of the network. And of course, right now, please remember, give your receipt if you already buy some sensor and some of the tools. Okay. The sensor cost will be a very important issue. Okay. And the next is the hardware constraint. And also we need to think about the media of the transmission. Okay. And this is a very good index that you need to think about your own environment, because this is case by case or case by case. Okay, and then you can choose what kind of the sensor network topology. Okay, and finally, please care the power consumption at all. So right now, I would like to show you very quickly for the basics of the wireless sensing network routing protocol. Okay, the first one, very simple and a very straightforward one, is the data to centric. One of these using flooding. I mean the flooding to transmit all the data like the flood. Okay, for example, from A to D, they're using the flooding. Okay, the advantage is this kind of the flooding protocol is very reliable. But however, right now this is turn TTL, time to live. I would like to say this kind of the flooding will have a maximum of the power consumption. Okay, so you need to check out if you try to use the flooding. And if you try to improve from the flooding, because there's one of the advantage is that one node maybe receive repeat signal. Okay, so if you try to improve that this problem, we may using a gasping. This is randomly choose some nodes to forward. Don't like the flooding. Flooding is everywhere. I broadcast the message to everywhere, right? But the gasping, maybe you randomly choose one of the direction to transmit the data. However, this kind of the gasping method will maybe have some of the delay. The chance of the delay. Okay, So for the next, I would like to say each method is improve. So the next is the spin. This is the show name with the sensor protocol for information via the negotiation. What is that? It's just like what we call the handshaking. Hello, and I confirm you already received my signal and you already check out. So this is a negotiation and what we call the handshaking or handshaking. So there's some of the node. ADV is mean that the node has the metadata to share. And REQ, the node needs some of the data. And finally, is the data itself. So the first two is the different kind of the characters. Okay, and this kind of the spin may reduce the overlap and the implosion. Okay, and the metadata replace the raw data. I mean that I need to send a metadata first. Okay, not original raw data. So this is the a figure to show you how the spin works. And this is the A. What is A? Check again. ADV. The node has the metadata. I mean that the ADV is the observation with the observation data can transmit. Okay. So A said, I have a data can transmit. Okay, to the B. And the B receive that message and say, yes, I need that. Please forward your data to me. So this is like the requirement or request. I would like to say request or request for the data. And A transmit the data to the B. Okay, so this is a spin with the negotiation. And the B next change to the ADV. He said to all of this and say, I have the data. Who wants the data? Who wants the data? Okay, so 1, 2, 3, 4 nodes say, yes, please forward your data to me. Okay, so this is the spin. Okay. And compared to the spin, I think this is another what we call a direct diffusion, DD. Okay, much enhanced in negotiation. Okay, so this is the source. Okay, and we already have some of the naming, interesting, gradient, data propagation, and reinforcement. So let us see in the final, maybe here. I still need to go back. Okay, the naming means that I have a data first. And interested, like the request, I have an interest to have your data, okay? But you can find a much complex negotiation we may need to use. Okay, so this is a source. And finally, this is a sink. And then this source said that I have a data can be diffused to anywhere, anyone to try to request my data. Yes, sink say yes. So they give interest from the different node. This is a light blue one. And what is the gradient? It means that the source will find a gradient to the sink. And for during this process, I would like to say the source will optimize which gradient, which path will be much efficient. Okay, So they choose a gradient to the sink here and transmit the data. And finally, give the reinforcement, means that to enhance the stability of the data transmission. Okay, so this is a DD, means that I have a high level of the sink because I have a much more flexibility and the reinforcement between the negotiation and have a very good efficient to transmit the data. This is the DD. So actually right now, the wireless sensing network mostly use the DD for the very quick transmission and the receiving the data. Okay, so I think right now we already have a class dismiss time, and let us to check out. Okay, I already installed that. So please, you need to install your OS by yourself. Okay, so maybe just wait 1 minute. I will show you the result.
If you connect to the laptop, it will supply power. If you connect to the laptop, it will supply the power, or we have to put the power with this and.
Yes, you just put a simple power to the Raspberry and find some screen.
No, I mean like the power supply is from the computer, or we have to put this like the Arduino. Or?
I would like to suggest using the adapter.
No, but
no, not from the laptop, because this kind of the computer need more power consumption. So the USB, I don't think this is enough for the power supply. Yes. Okay. Okay, you can find here. Okay. You can check out because we are in the Taiwan. Okay. Use the English language. Okay. So when you finish, you can directly connect to your Wi-Fi. And just as I said, you need to, if you try to use a VNC, please check here, Raspberry Pi configuration, and open the VNC. Open the VNC here. And then you can use the remote control with the VNC, like the TeamViewer. Okay. Any problem? No? Class dismissed.
Okay, yeah. I was thinking like I didn't put this one first. Okay,
Oh.
I see. Okay, and then we the HDMI here.
Yes.
Okay.
Okay. Okay.
Thank you.
Yeah.